PLCs, or programmable logic controllers. Yeah. Some of you are familiar, some of you not so familiar. So, module learner outcomes. So this is a level 4 module, and on successful completion, you'll be able to explain like the design, the architecture, the makeup and characteristics of a PLC in general. More specifically, we'll be working with Mitsubishi FX series PLCs, but I'll work with quite a few different types, and once you get used to one, it's not that difficult to learn how to work different types. You'll be able to explain PLC to personal computer and PLC to PLC communication techniques. So you'll do a little work in an assignment about how PLCs interface with touch panels that operators can put information in and read information from, and something called SCADA systems or software. Okay? Well, the most important part of the module is that you'll be able to demonstrate the techniques and languages available to assist in development of structured PLC programs, and write and produce, test and debug a significant PLC program. Okay, so they're the 4 learning outcomes. In terms of assessment, the module is assessed by 2 assignments. The first one is a written assignment of 2,000 words. It covers learning outcome 1, the operation and architecture, and learning outcome 2, communication and interfacing. And it's worth 40% of the overall mark. Okay. That will be issued, can't remember when I set it, I think it's around about the 3rd week, something like that. Okay, might even be next week, let's see. And run for 4 weeks. So my standard assignment thing with the whole course team, there are a few anomalies, and assignment 2 here is one of them, is issue, 2 weeks later, draft hand-in deadline, 4 weeks after issue, final hand-in deadline. The idea of having an early draft hand-in deadline is it encourages you to get something done and get some feedback on it. So make an early start instead of leaving it till the last minute. Get some feedback on it and help you to improve your work. Okay. So 4 weeks from issue, you'll be expected to hand the final version of that in. And the deadlines are deadlines. There's no going away from those. You'll hand your work in online. The new people will be shown how you do that tomorrow. Okay. There is a system where you can apply for an extension. You would need to do that in advance, and that is to the university and not directly to me. I do get a small say, okay, but the final decision isn't mine, and we did have a couple of people turned down last year. So you just need to be careful about that, okay? You need to provide evidence. It won't be just, I had too much work. And certainly you won't get it if you say, I lost my memory stick or anything like that. Okay? That will go down as no work submitted, and that will go down against you as one of your 3 overall attempts to complete a piece of work. Alright? So the second assignment is the programming assignment. And that's one that goes outside of that 4-week standard thing. It will be issued about halfway through, possibly even before assignment 1's been handed in. Because it takes a length of time, you'll be spending a lot of time here doing the program and writing the documentation for that. And some of that you won't be able to do away from here. So it runs for the rest of the module. The hand-in for that assignment is the last week. Yeah, and part of it is me observing your program successfully operating at the end of that period. Okay, so that one does run longer than normal. All right. Any questions so far? No, we will move on to history and development of the PLC. I'm going to go on and on about this too much. But the programmable logic controller PLC first developed by a company called General Motors, 1968. Prior to that, production lines usually controlled using relay panel control systems. And having worked on a number of them in my life in industry, they can be a bit of a beast in terms of fault finding when you get issues, because thousands and thousands of wires, thousands of terminations, and lots of problems. So, complex production lines using relays, range of problems, reliability getting worse due to the large number of relays. Control cubicles with well over 200 relays are quite common. The ones I used to work on had that number in easily. Maintenance problem is increasing. If you think about it, those relays have got at least 10 terminations on them. Yeah, and those terminals might have more than one wire on them. That's a lot of wires, a lot of terminations to on a daily basis. Terminals come loose, you get intermittent problems, so that's an issue. Control panels with over 200 relays means a total of 1,000 contacts in the circuit, each having at least 2 connecting wires, resulting in well over 2,000 cables. Fault in any one of the contacts or cables is difficult to trace, particularly if it's intermittent, because you can't find a fault that isn't there. Okay. Difficulty, the other thing is the difficulty in making changes to that system. So you want the machine to work in a slightly different way. With old relay-based systems, that'll probably be adding more relays in the panel if you've got room, completely rewiring part of the circuit. Whereas also often a relatively small change in the control requirements result in a complete rewire or partial rewire the whole panel. You've got to fit new timers in the front, new push buttons, all that type of thing, get wires out to the machine. All difficult things to do on a machine that's already in use. So, the PLC was designed to be a replacement for relay-based control logic. The original target set was to have a system that you could program easily, and when you wanted to, reprogram it so it would do something different. A solid-state system based on transistors and integrated circuits, making it suitable for unhealthy environments, ones that are quite harsh, dust, ingress of moisture, that type of thing. More reliable in those terms. A system more reliable and easier to maintain than relay-based controls that were in frequent use then, making plant downtime and maintenance lower. And a system that was smaller and more cost competitive than the relay panels that was designed to replace. These industrial relays aren't cheap. You know, I don't know what the price of them is now, but I reckon when I was working they were 40, 50 quid. And, you know, you can get a small PLC now for not much more than that will do the job of about 10 relays maybe. Yeah, well, that's, you know, that's come originally from General Motors, so, which isn't Chinese. Chinese just do it cheaper. Looking at the PLC versus the personal computer, because that's not impossible to get interfaces for a personal computer, as that computer stands there, to be able to connect it to pieces of kit and get it to control things. However, the technology used in PLCs is the same as that used in a PC, but the way it runs a program is different, as you're going to see. The PLC has advantages in control situations, not always, but it's relatively easy to understand and can quickly be modified. So the programming language that's been designed is much easier for a maintenance engineer working on the shop floor to understand and be able to alter or to interrogate than it would be if that was a control program written in C+ or Pascal or one of the other PC programming languages. Relatively fast response to process situations, a wide range of timer and counter functions. So where you would have to completely write a timer function in a C+ program, there's a timer function already been programmed. As you'll find out, those of you that haven't done anything, you just use that function. It's really easy. The bottom end of the range of PLCs, the small ones, are cheap enough and are viable to replace systems that only have about 4 relays in. It has become now really viable to get rid of old relay-based systems and put a PLC in because they're so cheap at the bottom level. Special interfaces that are available that can handle analog signals, and we'll be talking about them in a week or two's time. High-speed digital functions, boards to do temperature control and motor control and so on. And there are also a range of simple and more complex operator interfaces available, better known as HMIs, human-machine interfaces. Okay. And again, we'll be talking a little bit more about that in a later week. The differences between the two. PLCs are designed and packaged for the industrial environment out of the box. They all are. They'll have an IP rating. Okay, they won't like it if you throw water at them, but they are designed to work in hot, cold environments, where a standard PC out of the box may well not be in that sense. Okay. The inputs and outputs are isolated to protect the system from external high voltages and transients. So there's inbuilt isolation between the internal workings of the PLC and the extreme voltages that it might experience from outside influences. And we'll go into more detail about that in coming weeks. The programming is by simple ladder diagram in the main. There are other ways to program PLCs. I've never tried them out because I don't have any problem with the ladder diagram way of doing things. Okay, it represents the circuit rather than complex languages like C or Pascal. So, the issue there is if your electrician can understand a relay circuit diagram, that's an easy convert to a PLC ladder diagram, or reasonably easy conversion. Recent IEC 1131 standards introduced other methods, so manufacturers of PLCs do structured text, sequence charts, and function block diagrams. They are all other different ways that you could program a PLC, but we're going to major on the ladder logic. That's what I know, and I believe that's the way most people would understand how these systems work. The way the PLC treats the stored program in a continuous scan is different to the way microprocessor-based systems behave, or PCs behave. So again, next week we'll go through in detail this process scan thing and what the implications of that are. Because it does have implications, but it works for industrial applications these are being used for. So, different types, and like I say, we're majoring on Mitsubishi because that's what we've got in the main. We have got some other PLCs here, but our biggest body of PLCs is Mitsubishi. You're going to be, depending on how many turn up each week and how many's in the group, I might end up having to put one person on a slightly different PLC, but it doesn't make any difference whether you're using the FX1 S PLC or the FX3Gs that most of you are going to have. to the exercises you're going to do, it just makes no difference whatsoever. So that, you know, don't worry about that. But we're looking at unitary and modular PLCs. Unitary provide little or no scope for expansion, and there is no distinct line between unitary, modular, and the rack mounted we're going to look at in a minute. The lines are very blurred. Generally, on the lower end, there's little or no scope for expansion. You bought that PLC, and you can't really add to it or change anything afterwards in terms of its spec. But it can have the advantage of being really, really small, and I'm talking that size, you know, like a tennis ball size. And it's economical. This is the one that would be economical to replace systems that have only got like 4 or 5 relays. We then move, as we move up the range, we move into what we would term a modular type PLC, where you'll buy a base unit, and that base unit will have some basic digital input and output on it, and then you can add to that, usually connecting to it via some kind of ribbon cable, extension modules. And they can be extra input outputs, they can be analog inputs and outputs, motion control, and so on. Okay? But you buy a box standard PLC with its own power supply for the inputs and outputs, and then you can add to that. But there are some restrictions on it. Okay, with Mitsubishi, that's up to 8, or was at the time of writing this. And expansion models here are separate units that clip to the side or connect via a ribbon cable. Okay. Now, one thing with that is you install a modular and you reserve space in your panel for that. If you want to add to that with more I/O, there's the issue of, have you got space in the panel? This can be solved a little bit by the third type, the rack mounted. Because what the rack mounted is you buy a back plane or rack that's just a rack of connectors. And you can even connect them together to make even longer racks. Okay? And then what you do with these is you choose a particular power supply that suits your needs, that's got the current rating you want. You choose a CPU card that's got the right speed of processor for you. You choose a memory module that's got the right amount of memory in it you want. And then you choose each of one of your input, output and control cards, and they all plug into this rack and connect together with the connections at the bottom of at the back of the rack. So what you do here is buy a rack slightly bigger than you need, and you've already got some room for expansion. So here we've got the most flexible system in terms of expansion, and we can choose how powerful it is. The big disadvantage here is rack-mounted PLC systems, expensive. If I was to guess off the top of my head, I'd say you'd be lucky to get a basic rack-mounted setup for under about 1,500 quid. And I don't know if I'm right, but I don't think I'll be far out. By the time you've bought the rack, the power supply, CPU card, the memory card, and at least one input and one output card. Okay. So they're the general 3 types of PLC, right? But the lines between them are blurred. For instance, the most recent injection and blow molding machines I worked on in industry had a rack-mounted PLC that had 2 CPUs in it. So it had 2 processors. The machine had so many inputs and outputs, and it had a lot of analog processing on it. When they tried to develop it with one processor, couldn't keep up, kept lagging. So they put one CPU in to handle the analog processing, and the other CPU in to handle all the digital stuff, and then they had to use internal functions to get those 2 CPUs to talk to each other. So systems can be considerably more complex when you move up to rack mounted. They were Japanese, by the way, not Chinese. Okay. So there's another page there about the rack mounted maximum performance. You can get a variety of rack widths, so to suit your needs. Lots of different types of card, and they simply plug in, and it generally aids further expansion in the future. So if you want something to be future-proof, you know, these things will run whole production lines, let alone just one machine type of thing. Okay. When you're looking at selecting a suitable PLC, these are the kind of things that you might need to consider. First of all, you'd want to count up the number of inputs and what type they needed to be. And we'll talk a little bit more about different types of input probably next week. You'll need to know how many different outputs you need and what type they are, and in particular what voltages you need to handle. Whether you need any expansion capability beyond that number of I/O, and you'd be really foolish if you counted up the inputs and outputs on your machine, found that you needed 14 and 8, and there was a PLC with 14 ins and 8 outputs, and you bought that PLC. You'd probably be wiser to buy the next one up, because you'll have forgotten something without a doubt. PLC power supply doesn't need to be AC or DC. In remote locations, you know, you might be running these things off a battery that's backed up or charged up by a wind turbine up on the roof. So you might want a low voltage system running off DC. So that would be a consideration. What capacity of storage you need for your program, if we're looking at kind of a bigger application, that might be important. Processing speed. Some applications, the analog example I gave you a little while ago, is an issue where processing speed might be of interest to you. Whether you need a capability to network with other systems is something that you need to look at. The programming software, which in the main is megabucks. So if your company uses a particular type of PLC, you're probably going to want to stick to that, because otherwise you've got lots of different megabuck software to buy. But generally they don't work with each other. Preference for a manufacturer, which I've just covered really anyway. Once you've chosen a manufacturer, do you really want to choose someone different? And also cost would obviously be a consideration. Are you all okay? Am I going too fast for anyone? No? Good. So, programming software. PLC manufacturers generally have their own proprietary software package for programming. Mitsubishi, that we're going to use, have a range of different software packages to cater for a range of all needs. When I first got involved with PLCs, that must have been about 1980 something or other, and I just had one left. I was on nights, I had one left on the bench with a rough précis of what they wanted me to do with it. See if you can program this thing to do this. And at that time I was programming with a little handheld thing that clipped on the front of this F-series PLC, and you actually programmed it in the instruction language that sits behind the ladder diagram. I had no way to store programs at that point. I think we got a tape deck interface at one time, so you could actually transfer your program to tape, and then eventually we got laptops and different things. So it has developed a long way from there. GX Developer, basic level ladder logic and sequence function chart programming and documentation software. That's what we will use, okay? Because it's generally the easiest to use in terms of you haven't got a lot of clutter of all the other things and the navigators that you get with the other more complex programs. So whilst we've got GXWorks and IQWorks, there's a lot of clutter on the screen, and it's like these programs are all customizable interface-wise, and ends up a bit of a minefield. So I've steered clear of that at this stage, because we don't need that extra functionality. GX Developer will do everything we need to do. GXWorks is ladder logic and SFC program software to handle multiple PLC programs in an integrated workspace environment. So you can work on multiple projects at the same time with that software, which you cannot, as far as I know, do in GX Developer. IQWorks is a high-end integrated workspace program, so you can manage multiple projects across a range of PLCs, motor drives, and human machine interfaces. So you can work on your program and of not only the PLC, but of the HMI as well in that IQWorks program as a complete package. So you're looking at, for instance, if you're in maintenance, the most you're going to have is something like GXWorks. You're not in the business of manufacturing machines. Howard he's in a company where they manufacture machines, so they might well have used something like IQWorks. I don't know what type of PLCs you use, but you know, if you're just in maintenance like I was, we made plastic bottles. We didn't make machines, so all we needed is the basics to be able to fault find on a machine, and GX Developer would do that. So on this course, you will learn how to program and write the documentation for your program using GX Developer, and any of you guys that have done the programming here will have used GX Developer, I would think. Alright, so the next thing we're going to do is actually get started on having a go at programming these things. What I'm going to do is just go through the first couple of slides, and then I'll let you go away for 20 minutes and have a quick coffee break, and I'll get Chris up here and we'll get some of the gear out so you're ready to go. By the end of today, you will know how to write a basic program, have a look at a little bit of ladder logic, transfer it to PLC, and just generally get everything connected together. Right? So, when you there's a few important points about GX Developer projects. Okay, a GX Developer project, when you save it as a project, actually on your drive saves a folder with that project's name, and inside that are a lot of files, and I think there's even a subfolder or two. What this means is that you could come up against issues if you try and open a GX Developer project like you do a Word file by double clicking it. Yeah, you need to open it by opening the software and go into the open dialog. It will then open the project properly, because in the software it will recognize a folder as a project. So what you need to do for your PLC programs is create on your memory stick a completely separate folder for your programs, separate from the files that you write your assignments in, for instance. Okay, so that's what the first little bit is all around. Just make sure that you set up a separate place to save all your stuff. Please be aware, as I've already said, lose anything that's important assignment-wise, I'll just say you should have had it backed up. So save it in your network area here, and save it on a memory stick, and possibly save it somewhere at home as well, or in the cloud somewhere. You can get a version. You have to go to I'll have to get the web address, but it's mitsubishiautomation.co.uk. I have to sign up, and then you can get a free version that does up to 2,000 steps, I think, which is actually plenty for what we want to do. But you've got no way that you can simulate your program. What you could use that for, in terms of getting your assignment work done, what you could do away from here, is tidying up a lot of the documentation stuff. But I want to try and avoid you saying I'm going to do all the documentation at home, because I think documentation, or the basics of it, should be an ongoing process as you write the program. Because you're probably going to be wanting some help from me, and if you haven't put any comments in and don't name anything, I'm not going to understand what your program's trying to do. So documentation as you go along is important, but you would be able to update and tidy that up at home if you've got that software. I'll have to check back and find exactly how you get it out. Yeah, what each of the elements is, in terms of a short what's called alias, as well as a longer comment, and we'll talk about that when we talk. I think we won't touch on documentation till next week. But I've got a standard that I'm going to expect you to achieve in terms of documentation. All right. So what I suggest you do is create a folder for PLCs on your USB drive, and in that folder you can restore any associated documents. So if I give you any Mitsubishi manuals, you can store your and you can choose a slightly different system to this, of course, your assignment files and anything general inside that folder. Also inside that folder, create another folder called PLC Programs and put all your projects inside there. By all means have subfolders as well if you want to. Okay. There are one or two little routines that you'll write early on, just practice routines, that might become useful in your program and later. So, you know, if you think that's going to be useful, one particularly is a cycle and timer, a timer that turns a light on for X number of seconds and off for X number of seconds. You may well find that useful later on if you want to make a light flash or something on your main program. All right, so save that, and then you can look back at it if you can't remember how it worked. So the kit that you're going to use is a rack-mounted PLC, looking like this. Going to need one of them. Okay. The FX3Gs are direct connect to USB. So at the moment I've only got 1, 2, 3, 4, 5, 6, 7, 8 people in the room. So you should all be able to have an FX3G. You're going to need a kettle lead or a mains lead for the PLC. That plugs in around there somewhere, and there's a red switch beside it. The USB cable for obviously plugs into the USB port on your laptop. And then you'll want one of these boxes. That's what we're going to use for input simulation today. So it's got a green push button on input 0. It's got a red stop push button so we can do a stop-start function. And I've got some switches on the other inputs. And I've got some LED lights on connected to the outputs. So that's the kit that you're going to need for the practical that we're going to do today. And then when you open the software, GX Developer, so you might find it on a desktop. If not, you'll find it in all programs somewhere, and if you can't find it, I'll help you. Okay? So they keep moving these things around when they install the software on a laptop. So we write these kind of guides and then they change it. But it will be there somewhere. When that's open, you'll notice this might be slightly different because you can move these toolbars around. And what you're looking for when you're working with this software is to have as much possible in that programming area as you can, because you want to be able to see as much of your program in one go as possible. So I tend to say we need to get as much real estate here as we can. Alright, to start with, when no project is loaded, that's all you've got. Open a project or start a new one. Then, what you'll get once you actually set up your first project, and these notes go through that in a minute, but once you've told it what PLC you've got connected and what type of programming you want to do, then the screen goes something like this. You've got much more available to you, and you can see I've actually tidied up the toolbars, so there's less space taken up by toolbars and more space for actual programming. You've got a navigator over here. What you're going to want to do in the navigator is navigate between the documentation page and the main programming page, which is what this is on. And then all this area over here is where you write your ladder logic program. The current cursor is marked most of the time by a blue box, but there are times by default you're in overwrite mode, and there's a key on any computer that says insert. And what that key is a toggle between insert and overwrite, and generally when we're using Word we stay in overwrite mode. But if you change to insert mode, where it will put another instruction between two instructions, that cursor, that box goes purple, so you know you're in insert mode. And more of that later. So over here, this is your ladder diagram area. And these two bars here, think of them electrically like positive and negative. Ladder two rails, if you like. And then you draw your ladder diagram of contacts and connections between that point and that point. And what you've got initially is the end instruction. And you cannot delete the end instruction. It's in there automatically, and you can't get rid of it. When you start writing, what you do is you start to write an instruction there, and it will shift the end instruction down one space, and you'll be working with a new line, and you'll see that later. What I'll do is, while you're away for break, I'll get one set up on here, so I can run through a little bit of this before you actually go off and do it yourselves. Okay? And next, so that's what it looks like when you start up. And up here you've got all your different icons at the top here that allow you to do different range of functions that you need to do. So once I'll go through that with an actual PLC when you come back, and then you'll go through the notes on the pages that will help you to set up your first program. And I'll just run through that as well anyway, so you can see what it looks like on the screen. Alright? So if you would like to go and have a quick coffee now and come back here, let's say I'll give you a little bit extra today because I want to go and see if I can get these registers sorted out. Come back about past. Alright?